C4, C5, C6. Okay. Okay, so this is the graph. We will continue our topic. So yesterday we have discussed that what is local maxima and minima, and yesterday we have written one point that the local maxima and local minima exist at the critical points. Okay, local maxima and local minima exist at the critical point. So who can tell me what is the critical point? Abdul, can you tell me what is the critical point? Abdul,
Sir,
can
the
you?
points at which the values are equals to 0.
Yes, the point at which f dash x is 0, and there is one more point that
Uh,
f. Hmm,
Derivative is not differentiable at corner point.
very good. So critical points are those at which the derivative of the function is 0 or the derivative does not exist. Okay, doesn't exist. Or we can say the function is not differentiable at that. So for example, this is a critical point because at this point, the function is not differentiable. So what's the critical point? It is the point at which the function, at which the derivative is at the 0 or the derivative do not exist. The function is not differentiable at that point. Why? Because at that point, we have a corner. Okay, at the corner, the function is not differentiable. This we have already done. So next, again, the same point, critical point. What is the critical point? A point C in the domain of a function f at which either this is 0 or f is not differentiable is called a critical point of f. Okay. So what is the critical point at which the derivative is either 0 or the function is not differentiable? That is called the critical point. So this we have already discussed. Zed, we have just run. So I hope this point is clear to you. We have already discussed this point. What is the critical point at which the derivative is 0? For example, here this is the critical point because here the slope of the tangent will be 0 or the function is not differentiable. That is at the corner point. Okay, so critical point we have discussed. Next we have a theorem. Yes, the theorem is let f be a function defined on an open interval I. Let f be a function which is defined on this interval. Suppose C is a point which belongs to this interval. If f has a local maxima or a local minima at x is equal to c, then either f dash c is equal to 0 or f is not differentiable at c. This is the same point which you have noted down yesterday. Okay, I have discussed this point already with you that if local maxima and local minima exist, then it will exist at which point? At the critical point. We have already discussed that if a local maxima or local minima exists, then it exists at the critical point. The same thing is written here. They're saying that this C will be what? At this point C, the derivative is 0 or f is not differentiable. So that means this C is a critical point. So I hope this is clear to everyone. Now, the converse of this theorem is not true. Okay, that is a point C at which f dash C is equal to 0 or f is not differentiable need not to be a point of local maxima or minima. Okay, so I'm saying that if local maxima or local minima exists, then it will exist at the critical. I hope this point is clear to everyone, but the converse is not true. That is, if a point is a critical point, then it is not necessary that at that point you have a local maxima and minima. Okay, why? Let me draw a graph for you. Suppose we have this graph. Suppose we have this graph, okay, and I will draw this curve. So this is the origin. At origin, if you will differentiate this function, you will get a 0. The derivative will get 0 at this point. Okay. At this function, suppose x cube, fx is equal to x cube. If you will differentiate this, f dash x is equal to x square, you will put 0 here. So you will get a 0. So this is a cubic function graph, x cube graph. If you will differentiate this function and put the origin, you will get a 0. But who can tell me? Rifat, will you please tell me that this origin is a point of maxima or a point of local minima? Rifat, can you tell me that this origin is a point of local maxima or local minima? Maxima? Okay, who can tell me next? Zed, can you tell me that this origin is a point of local maxima or local minima? Zed, this point is what? Not very, very good, Zed. Very good. So all of you, please check here. If we will compare the value at this point with the right side, so you can see that at this point, at this point, I will just give me. Okay, if you will check at this point, then at this point the value is lesser than the right side. If you will compare all these values, then at this point the value is lesser than the right side. But if you will compare with the left side, then at this point the value is greater than the left side. So this point is neither a local maxima nor it is a local minima. Okay, so you can see here that this is a critical point. This is a critical point. C is a critical point, but at this critical point, we do not have a local maxima or local minima. And such a point, I will tell you, you know about 2 points, point of local maxima, point of local minima. But if we have a point at which we do not have local maxima or minima, then we will say such point as point of inflection. Okay, such point is called the point of inflection. This one, point of inflection. Okay, so what is the point of inflection? The point at which fx is neither local maxima or minima. I hope this is now clear to everyone. This remark, what is this remark? The converse is not true. If you have a critical point, then we can't say that at this point we have always a local maxima or minima. No, this is not true. Okay, there exists some critical point at which we do not get the local maxima or minima, and such a point are called the point of inflection. This is neither maxima nor minima. So I hope this is clear to everyone. So please note down this and raise your hands. Once it is done, then we will continue this topic. And if anyone have a doubt, please let me know. I will again explain this to you. Everyone, please. Okay, Said, good. Abdul, Fahd, and Rifat. Okay, Fahd, good. Okay, Rifat, very good. Abdul, please raise your hands once it is done. Okay, Abdul, great. Now, next one. Next, okay, so we have a two tests to check that a point is a point of local maxima or a local minima. We have a first derivative test and we have a second derivative test. Okay, but we will start with the second derivative test because I need to start some word problems today, and that we will solve by using second order derivative test. Second is quite simple than the first one. Second derivative test is quite simple than the first one. Okay, so that's why in majority of the question we will always use the second. In case the second test fail, we have a situation when the second test will fail. So in that case, we will again go back to the first derivative test. Okay, so let me start this. So this, okay, so this is a second derivative test. Now, suppose f be a function defined on interval I and c is a point which belongs to I. Okay, let f be twice differentiable at c. So the function should be twice differentiable at that point. Then, now the first point is we will say that x is equal to c is a point of local maxima if f dash c is equal to 0. X is equal to c is a point of local maxima if f dash c is equal to 0. And when you will differentiate it two times and put the value, this value c, then you will get a less than 0. Okay, so we will say that this is a point of local maxima. If you will differentiate it and put this point, you will get a 0. And when you will double differentiate it and put this point, you will get a less than 0. This value fc is the local maximum value of the function. Now, for local minima, what will happen? This will become opposite. So x is equal to c is a point of local minima if f dash c is equal to 0 and second order derivative is greater than 0. In this case, fc is a local minimum value of f. Now this test will fail if you are getting f dash c 0 and when you double differentiate it and put the value c, then you are getting 0. So this test will fail in this condition, in the third condition. So what we will do in the third condition, then we will again go back to the first derivative test. Okay, first derivative test we will do later on. First of all, we will start with this one, second order derivative test. And the word problems based on second order derivative test are very, very important. Okay, we can expect a question in your final exam from this. Okay, so if for the third point in this case, if we in this case for the third point, if the test fail, we go back to the first derivative test and find whether there is a point of local maxima or a minima or a point of inflection. Okay, so this is your second order derivative test. Please note down this. I know this is not clear to you. So note down this, then we will try a question and we will understand from example. So please raise your hands once it is done. Okay, so Abdur, what we have to do, first of all, we need to differentiate the function and we need to find the critical points. Okay, that can be found by equating this with 0. Then we will again differentiate it and put this critical point. If we are getting less than 0, then we will say that this point is a point of local maxima. Abdul, please note down all this. Okay, then I will take example and I will again explain this theorem from an example. Okay, so all of you please raise your hands once it is done. Okay, Zaid, very good. Okay, Rifat, very good. Abdul and Fahad, please raise your hands if it is done. Okay, Abdul, good. Who is left? Fahad. Okay, Fahad, very good. So we will start a question. For example, this question. Find local maximum and local minimum values of the function given by fx is equal to this one. Okay. So we need to find the local maximum and local minimum value. So please check here. How can we solve this question? We have this function fx is equal to 3x to the power 4 plus 4x cube minus 12x square plus 12. Find the derivative of this. What you will get? 12x cube plus 12x square minus 24x. We get this. Okay. Now equate this with 0 to find the critical points. So put f dash x is equal to 0 to find the critical points. We need the critical points here to find the critical points. Critical points. Okay. So 12x cube plus 12x square minus 24x is equal to 0. So take out 12x, take out this common. So what you will get? X square plus x minus 2 is equal to 0. This is 12x, and here please factorize it. 2x minus 2 is equal to 0. So from this you will get what? 12x, take out x common, x plus 2 minus 1, x plus 2, x plus 2 is equal to 0. So 12x, and here you will get what? X minus 1, x plus 2 is equal to 0. So what the value of x you will get here? First, x is equal to 0. Second, x minus 1 is equal to 0, which will give you x is equal to 1. And third is x plus 2 is equal to 0. So you will get here x is equal to minus 2. So what are the critical points here? X is equal to 0, 1, and minus 2 are the critical points. Okay. So all of you, please raise your hands if it is clear till now. You were lagging for. Oh, okay, Abdur, if it is a problem. Uh, not sure, Abdur, from which side you have this problem. Now, is it fine, Abdur? I'll switch off my video. Maybe that will help now. Is it fine now?
Yes, sir.
Okay. So, okay, Zaid, I got your response. Abdul, Fahad, and Rifat, is it clear up to this step?
Yes, sir.
Okay, okay, Rifat. Fahad, up to this step, is it clear? So this we also do in the increasing decreasing. So I hope this is clear to everyone. Fahad, this clear?
Yes, sir.
Okay, great. So we get the critical point here. Abdur, if you will again face an issue, then please let me know. Okay. Now, these are the critical points. Now we need to check that these points are what? These points are local maxima or local minima. So how we need to check this? If you will check, if you will turn your page, then you can see we have differentiated the function 2 times. So we have this function, again differentiate this. So f double dash x is equal to, this is what? Here we will get 36x square, 36x square, then plus 24x plus 24x minus 24. Okay. Now put all the points here. So f double dash, first of all put 0 because 0 is our critical point. Check here. So put 0. So you'll get 0 plus 0 minus 24. So this is less than 0. Hence, x is equal to 0. X is equal to 0 is a point of is a point of local maxima. Okay, if we will get a less than 0, then this point is a point of local maxima. Now this theorem is clear to all of you. Please raise your hand. Abdur, Fahad, Rifat, Zaid. Now this theorem is clear to you? Okay, Rifat, okay, Abdur. Then Zaid, is this clear now? Okay, Zaid. Fahad, this is clear? Okay, great. Okay, so this is a point of local maxima. Now in the question, what we need to find the local maximum and local minimum value also. So here we get this is a point of local maxima. So what the function we have? Function is 3x to the power 4, 3x to the power 4 plus 4x cube minus 12x square plus 12. Okay. Now we get this point. This is a point of local maxima. If we will put this point in the function, then we will get the local maximum value. So put this point 0 plus 0 minus 0 plus 12. So which is equal to 12. So 12 is the local maximum value at x is equal to 0. Okay. So how you need to find the local maximum and local maximum and minimum value? You need to put that value in the original function. Okay. So I hope this is clear to everyone now. Now please note down this. Okay, and check for the rest of the critical points on your own and share your answer. Okay. Please note down this. Let me know once it is done. I will change the slide and then complete this question. Okay, further I will 1, 2, 3, 4, 5, 6. Okay, for at this step, I've just
Yes, sir.
different. I've just factorized this. Okay, x squared plus x minus 2. So there's a quadratic equation. I've just factorized it. Okay, so I've written 2x minus x because when you will subtract it, you will get x. When you will multiply this, you will get a minus 2x squared. Okay, Fahad? Fahad, is it fine?
Yes.
Okay. Sorry, Abdur, I have just checked your message. So your doubt is, should we not equate the value to 0? So we have equated the value to 0, Abdur. Abdur, will you please explain to me your doubt? Abdur? Can you explain to me in which step you have a doubt? We have equated with 0 to find the critical points.
So can you change the slide?
Yes, sure. For second derivative, no, Abdul. For second derivative, we will not equate to 0. We will differentiate it. Okay. For second order derivative, we will double differentiate it and then put the critical point. We will put the critical point. Then we will check what the answer we are getting. If we will get a negative, then we will say this is a point of local maxima. If we will get a positive answer, we will say that this is a point of local minima. Is it fine, Abdul, now?
Yes, sir.
Okay, great. So for 0, I have already checked for you. Now please check for 1 and -2 and let me know that it's a local maxima or minima. And also find the local maximum and minimum value. Okay, Zed. So 7 is the local minimum value. Okay, so 3 plus 4, 7. Okay, great, Zed. That is correct. Now please, Zed, check for -2. Good. Good, Zed. Now please check for -2. And anyone else, if they have checked for the critical points, then please share your answer. Okay, Zed. Very good. Okay, okay. So everyone, please share your answer. So 7 and -20. Very, very good, Zed. Your answer is correct. Fahad, Rifat, Abdul, is it done?
So for f of 1, we should take this same equation, 3x cube and this.
Yes, yes, this is the function, okay? This is the second order derivative. First of all, you need to check for 1 one is a point of local maxima or not. So for that, you need to put in the second order derivative. Okay. Further, is it clear? Omir, you were absent yesterday and today you have joined 40 minutes late. What's the reason? Omir, first reply me on the chat box. Okay. What's the reason why you are late 40 minutes? Fahad and Rifat, please let me know if it is done. Omir, what is the reason why you are 40 minutes late? Okay. And why you were absent yesterday? Okay. So, okay. So, Umir, we have started the Maxima and Minima. So please check the recorded lectures. Okay. Check the recorded lectures which we have done yesterday. And I will take a new question and I will again explain you this concept. Sorry, Umir.
Can you hear me?
Sorry, your voice is not clear, Umir. Okay, okay, Umir, then please message me on the chat box. Okay, Fahad, that is correct. But before that, Fahad, you need to check that x is equal to 1 is a point of local maxima or local minima. Okay, then how can we check that for local minima? That's fine. That's good. Okay, and you have find out the local minimum value. That is also correct. Now please check for -2. Okay. And Rifat, is it done? This question is done, Rifat. Okay, will you please let me know? X is equal to 1 is what? Local maxima or minima? Okay, so you are telling me for -2. Okay, so -2 is what? -2 is what? Local maxima or local minima? Local minima. No, that's not correct. Please check the answer refer. X is equal to 1 is the point of local minima and x is equal to 2 are okay. This is also minima. That's correct. I'm sorry. And you're getting -20. That's correct. Okay. Good refer. So I hope you also check x is equal to 1. Now, next is Firth. Firth, you have completed this?
Yes, I'm doing the last one.
Okay, great. Okay, for that's correct. Very good. So this is local maxima or local minima for because you need to put this -2 in the second order.
Local maxima.
Local maxima. Let me check this. So f double dash x is this one. So put -2 here. What you will get 36 minus 2 square plus 24 into -2. Next is -24. So here you will get what? 36 into 4 minus 48 minus 24. So here you have 144 minus 72. So it is positive, greater than 0. Will you check first where you have done the calculation mistake? Fahad, can you check where you have done the mistake? Fahad, writing substitute. Yes, that's the issue. Okay, always substitute in the second order derivative. By putting the value in second order derivative, you will get to know that it is a point of local maxima or local minima. Okay, once it will be decided that this is a point of local minima, then substitute in the function to find the local maximum value. Okay, so the deciding equation will be second order derivative. Once it is confirmed that it is point of local maxima or local minima, then put in your main function. Okay, so I hope this is now clear to everyone. Now we will start next question. Next question is find all the points of local maxima and local minima of the function given by this. Leave this question because there is a point of inflection. Okay, this is a very good question. So Fahad and Zed, please try this question on your own. In the meantime, I will explain this to Umair. Umair, we have done a point. We have done this topic, local maxima and minima. Okay, so I will explain this to you. Suppose we have this function, Umair. So if we will see at this point, let this be C1, then this function has suppose the value 4. Okay. If we will check this value 4, then this 4 value is greater than the neighboring values. You can see here. So if we have a value which is greater than the neighboring value, then that means left and right side both, then we will say that this is a point of local maxima. This is a local maxima. Okay, so Umair, local maxima doesn't means that this is a maximum value of the function. This doesn't means that this is a maximum value. Local maxima value means it is greater than the neighboring points. For example, if you will check here, this one, C2, then at this value is greater than the neighboring value. So we will say that this is what local maxima. If we will check this value, then this value is lesser than the neighboring value. Neighboring means left and right side both. So we will say that this is a point of this is a local minima. Okay. So as you can see that Umair here, that local maxima value is lesser than the local minima value. So this is what I'm saying, that local maxima and local minima doesn't mean that this is the maximum and minimum value of the function. Local maxima and local minima value means the value is greater than the neighboring points, and for local minima is this means that the value is lesser than the neighboring points. This concept is clear to you, Umair. Umair, please reply me on the chat box. This concept is clear to you. Rifat, the last question you have completed. Now please try this question, Rifat, okay, and share your answer. Umair, please reply so that I can start the question. Umair, once I will get the response from you, then I will continue this. Okay. All of you, if you have done this question, then please share your answer. Okay. And if anyone have a doubt, please let me know. Anyone can tell me what the critical points you are getting? Anyone can tell me the critical points? My voice is audible to all of you. Anyone will respond, please. My voice is audible.
Yes, sir.
Okay, okay, for thanks. Okay. So please, first of all, share the critical point with me. Not got. Oh, okay, sir. Then I will wait for others. Okay. If no one is able to solve this question, then I will solve it. So Fahad and Rifat, please share the critical points if you get the answer. Very good, Zad. It is correct. Now check that this is what local maxima, local minima. Yes, first we have to differentiate it. We need to equate with zero. Okay. Very good, Zad. It is correct. And Zad, can you tell me what the local maximum value you are getting? And Umair, please reply so that I can explain this to you. Very good, Zad. That is correct. Very good. Fahad and Rifat, please share the critical points or let me know if you have any doubt here. Very good, Rifat. That is correct. Rifat, please tell me the local maximum value. No, Fahad, that's not correct. Let me solve this question. So hx is equal to if sin x plus cos x. Okay. H dash x is equal to cos x minus sin x. Okay. Now put this very good, Rifa, that is correct. Put h dash x is equal to 0. So what you will get cos x minus sin x it equal to 0. Okay, now in such type of questions, for do not check this directly. Okay, because it will be very difficult for us to check two ratios that for what angle these two will be 0. So it will become quite tough for us. So what you have to do, shift one of the ratio to the right side. So minus sin x is equal to minus cos x. Cancel out this minus. So what you will get here, sin x is equal to Sin x is equal to cos x. Okay, cos x into, okay, and further we can write cos x into 1. Why we are writing here? Now cos x is getting multiplied with 1, so we can shift this in the denominator. So we will get sin x by cos x is equal to 1. This step is clear for?
Yes, sir.
Okay, great. Now sin by cos is tan, so we will get tan x is equal to 1. Now first, can you tell me for what angle of tan you will get a 1? Tan 45 degree? For tan 45 degree?
Yes, sir.
Yep,
Done.
great, great. Okay, please learn the standard angle values. So x we will get pi by 4. So there are more angles for which we will get a 1, but they said that we need to find the angle between 0 and pi by 2. So there is only a single angle. Now, is it clear for?
Yes, sir.
Okay, for now, can you tell me how you found that pi by 6 and pi by 2? Okay, no issue. Okay, Fahd. So I have find out this critical point. Now please double differentiate it and let me know that this is a point of local maxima or minima. Okay. No, Fahd, please try to learn the angle in terms of pi, okay? Because sometimes we will get some some lengthy angles, and the calculation by using pi it is very simple. Okay, so please try to learn the angles in terms of pi. Is it done, Fahd? Did you check for x is equal to pi by 4? Fahd, did you check for pi by 4? That it is a local
No,
min.
sir.
Okay. Fahad, is it done? Fahad, did you check this value? Fahad.
Yes, sir. I got local minima.
Local minima. I'm not sure that. No, that is not correct. Please check here. So, uh, h dash x is equal to what you get. This is cos x minus sin x. Cos x minus sin x. Okay. Again, differentiate this. Tell me first what you will get here.
Minus sin x minus cos x.
Very good. Now put this angle pi by 4. Okay. So we will get minus sin pi by 4 minus cos pi by 4. Now tell me first what is sin pi by 4? Sine 45 degree.
1.
1 by root 2. Okay, please learn the value. What is the value for this cos pi by 4? It is again 1 by root 2. Okay, so you will get what? Take LCM root 2. You will get minus 1 minus 1. So here you will get minus 2 by root 2. So here you will get minus root 2. Okay, so this means less than 0. Hence, at x is equal to pi by 4, so x is equal to pi by 4 is a point of local maxima. Now tell me further, at which step you have done the mistake?
Sir, in the fourth step.
Okay, okay. Now is it clear?
Yes, sir.
Okay. Now we have this function. We will put this point. We will get a sine pi by 4. Okay. Plus cos pi by 4. This is equal to 1 by root 2 plus 1 by root 2. If you will solve this, you will get a root 2. So root 2 is the local maximum value. Okay. So for please note down this quickly. Then raise your hand. We will start a new question. So Zad, Abdur, you were got disconnected. So we have started one question. Please wait, Abdur. We will then do a new question after this. Now we just have half an hour because after that you have a test. Okay. Fifth step, 1, 2, 3, 4, fifth. This one, first.
Yes.
So for we have done nothing here. Minus 1 is minus 2. Minus 2 by root 2. Okay, we will cancel out this 2. 2 can also be written like this. 2 is equal to root 2 into root 2. Okay, so root 2 into root 2 in the denominator you have a root 2 that will cancel out. You will get a root 2 here. Is it fine? First?
Okay, sir. Yes.
Okay. So please raise your hands once it is done. Okay, Fahad, very good. Okay, so the most important thing in this topic is word problems. Okay, And hopefully in your exam, you can expect in the final exam, you can expect a question from the word problem. These are very, very important. So all of you, please do a lot of practice for these word problems. Okay. Okay. Now I have given you a very simple question here. So please check here. The question is find two numbers whose sum is 24 and whose product is as large as possible. Okay. So sum of two number is 24 and product should be maximum. So what we will do, we will first of all assume the number. Let the numbers be x and y. Okay. So we can say x plus y is equal to 24. And here we have the product. So product P is equal to what? X into y. Okay, so up to this step, this is clear to all of you? Abdur, Fahad, Rifat, okay. Umair, can you hear my voice? Abdur, Fahad, Rifat, Zaid, up to this step, is this clear?
Yes, sir.
Okay, good, good. Rifat, Fahad and Zaid, this clear? Okay, Fahad. Zaid, I hope. Okay, good. Okay, now which function we need to maximize here? Who can tell me? Abdur. Abdur, can you tell me what we need to maximize?
So product.
Product. Very good. Now product is equal to x into y. All of you, please check this question carefully, because if you understood a single question, then the same concept you need to implement in each and every question in the word problem. Okay. The problem can differ, the figure can differ, but the basic concept will remain the same. So please check this carefully. We need to maximize the product here. This is given x plus y is equal to 24. Let this be 1. Product is equal to x into y. We need to maximize this. Okay. Now, Fahd, can you tell me how many variables we have here for this one in 2? In expression 2, equation 2, how many variables we have?
2.
2, x and y. Always
Yes, X and
remember.
Y.
Yes, very good. So always remember, whichever function you need to maximize and minimize, that should consist of only a single variable, not two variable, not two, three variable. Always remember, whatever the function we need to maximize, that should consist of only a single variable. Only single variable. Now, here we have two variables. So in the question, they will always give you some condition from which you can eliminate a variable. So from this, we can see that y is equal to 24 minus x. We have this condition x plus y is equal to 24. So from this, we can say y is equal to 24 minus x. Now put y is equal to 24 minus x in 2. So what you will get here, t is equal to x. In place of y, we will put 24 minus x. If we will open the bracket, then you will get what? 24x minus x squared. Now, who can tell me? Z. Z, this p now have how many variables? Z, this equation, yes, one variable. Okay, so all of you now please check here. Now we have reduced this expression into a single variable. So in each and every question, whatever you need to maximize or minimize, that may contain two, three variables. But finally, you need that expression in single variable only. So for that, they will always give you some condition. Okay, so always remember, we need to maximize or minimize something in such a type of question. For that, we need a single variable in the equation, and to convert that expression into a single variable, they will always give you a condition. If that condition is missing, then please read the question again and again. It is not possible that they will not give you any condition. They will always give the condition. So please always check the question carefully. Okay. So in all the word problems, you need to check two things. First, you need to maximize or minimize something. Second, they will give you some condition, with the help of which you will change the expression into a single variable. Now, this you know how to solve this. Okay, we will differentiate this. So whatever the variable you have, differentiate this with respect to that variable. So we will differentiate with respect to x. So we will get 24 minus 2x. Now put dp by dx is equal to 0, to find the critical point, to find the critical, points. Okay. Now what you will get here? So you will get 24 minus 2x. Very good, Zad. That is correct. Okay. So you can say 2x is equal to 12. Can we take x is equal to, yes, that's your wish. Okay, for then the equation will become in terms of y. So that is also fine. So this is 24, sorry. Yes, thank you. So x is equal to, here you will get 12. Okay, we get this value. Now we need to check that this is a point of local maxima or not. So what we will do, we have this dp by dx. What is this? This is equal to 24 minus 2x. Now we will again differentiate this. So second, again differentiate this d square p by dx square. So what you will get here? You will get a minus 2. Okay, and normally we always put the value. So x is equal to 12. There is no value, there is no variable. That's why there will not be any change in this minus 2. Now this is less than 0. So x is equal to 12 is a point of, observe. Can you tell me x is equal to 12 is a point of what?
So local maximum.
Local maxima. Very good. It's a point of local maxima. Is a point of local maxima. Now x plus y is equal to 24. So y is equal to what? 24 minus x. So put this value, y is equal to 24 minus 12. So you will get what? Y is equal to 12. Okay, so you will get y is equal to 12. Now, okay, so here we need to find two numbers. So whose product is large as possible. So we can say two numbers are 12 and, okay. So I hope this question is clear to everyone. Please note down this and raise your hands once it is done. Then I will give you a new question. If anyone have a doubt, let me know, but the concept will remain the same in each and every question. And please do a lot of practice in this word problem. If you have any reference book, do the solved examples. Okay. Definitely one question will come in your final exam from the word problem. They're saying find two numbers. Okay, Abdul, they're saying find two numbers whose product is as large as possible. So we just need to find the numbers. They're not saying that find the maximum value of the product. Okay, they're saying product should be maximum, but they're saying find two numbers. Is it fine, Abdul?
Yes, sir.
Okay. Okay, Zed. Very, very good. Okay, Abdul, very good. Fahad and Rifat, please raise your hands if it is done. Okay, Rifat, very good. Fahad, is it done?
1 minute, sir.
Okay.
Done, sir.
Okay, great. Okay, again, please note down this and raise your hands. All of you, please raise your hands. We need to do two more questions. Okay, Fahd. Okay, Zad. Okay, Rifat. Abdur, is it done? Okay, great. Now next question. Just give me a minute. Okay. So next question. X plus y is equal to 60 and xy cube is maximum. Now please try this question. Okay. Let me know if anyone have a doubt. Even I will write this for you. Here you have x plus y is equal to 60. And again, you can represent this by p only. Okay. P is equal to xy cube. Now please solve. Okay, Rifat, that is correct. Very good. Now please check for that point. It is a local maxima or local minima. Okay, Zed, very good. Now, Zed, please find the second number also. Zed, you got the first point. Now find the second number also. We need to find two positive number. And Rifat and Zed has done. Fahad, Abdur, please let me know if it is done. Or if you have any doubt, please tell me. Okay, Zed, very good. It is correct. Good. Very good, Rifat. It is correct. And Abdur and Fahad, I'm waiting for your answer. If you have any doubt, please let me know. Okay, Abdur. So please check here. P is equal to xy cube. So we can reduce this expression into a single variable in terms of x or in terms of y. Okay, Abdur, can you tell me that which is better to convert this in terms of y or in terms of x?
So in X,
In x, but it will be good if we will convert this in terms of y because we will check here. P is equal to, we will get 60 minus y into y cube. So there is no need to apply the cube formula here. Okay, that is also good. You can reduce this in terms of x, but then we need to apply the formula of a minus b whole cube. Okay, here there is no need to apply the formula. Now we will solve this. Find dp by dy. So this is equal to 180 y square minus 4y cube. Then put dp by dy is equal to 0. So what you will get here, 180 y square minus 4y cube is equal to 0. Now take out common. So what you can take out common, y square and 4. So what you will get here, 45 minus y is equal to 0. So from this you will get 4y square is equal to 0. Okay, which will give you y is equal to 0, or 45 minus y is equal to 0. This will give you y is equal to 45. Okay, y is equal to 0, we will say not possible. Why? Because if we will take y is equal to 0, then the product will become 0. Okay, if we will take y 0, product will become 0. So that's why we will not take this value. We will take y is equal to 5. Now, differentiate this second time. This is equal to what? 360y minus 12y square. Okay, we have differentiated this one. where this one. Now put this value d square p by dy square at y is equal to 45. Okay, so what the answer you will get here? Okay, Zad, good. So, okay, very good, Zad. Thank you. So 360 into 45 minus 12 y square, I will write 45 into 45. Okay. Now you need to do this calculation. It's your choice. You can do this, multiply both, then subtract, or the other method is I will take 45 common. So, and I will take 12 also common. So what I will get here, 12, 330 minus 45. So here I will get 12 into 45. This is just a calculation, so you can do this on your own. Okay, minus 15. Okay, we need to multiply this, and Zad has sent me the answer 8100. That is correct. Okay, so I'm not doing this calculation on my own. Zad has given me this answer, so I'm using this, but it is correct. 8100. Okay, which is less than 0. So if it is less than 0, we will say that y is equal to 45 is a point of local maxima. Okay, so if okay, now we need to find the value of x. X is what? X is equal to 60 minus y. So x is equal to 60 minus 45. So x is equal to what? 15. So we get two values, 15, and so two numbers are 45 and 15. Are 45 and 15. Okay. So I hope this is clear to everyone. Abdur, is it clear? Abdur, is it clear?
Yes, sir.
Okay, Fahad, this is clear?
Yes, sir.
Okay, great. Okay, Rifat, you have already done. Zad has completed this. Okay, so please note down this, Abdur and Fahad, and let me know. Then we will start your test.
Sir, why we don't take y is equal to 0?
Okay, if we will take y is equal to 0, then this product will become what, Fahad? Fahad, put in place of y 0 here. What you will get as a p?
0.
0. Okay, that's why we are not taking this. Product will become 0, so that 0 will not be the minimum value, maximum value, sorry. Okay. Okay, Abdur, very good. Fahad, is it done? Fahad, is it done?
Yes, sir. Yes.
Okay, great. Please note down this and again raise your hands. Abdur and Fud, please raise your hands if it is done. Okay, Abdur. Fud, is it done?
Yes.
Okay, great. So, homework is who have not completed the assignment 1 and 2, please complete those 2 assignments. And then again revise this topic maxima and minima. And if you will get the time, try to solve the solved examples of this maxima and minima. We will continue this topic in the next class. Okay.